Hello and welcome to the Abingdon Science Partnerships workshop on Marvellous machines with Mr. Thomas. This workshop is going to be about pulleys. Just like all machines, pulleys are designed to make a job easier to do. Pulleys have been used for hundreds of years, especially to help with lifting heavy things. They were really important on sailing ships. This is a model of King Henry VIII's ship, the Mary Rose. The sailors would have used pulleys to lift the sails, to load the cargo on board, and for moving the very heavy cannon into position for firing. Here's a fun history fact. Did you know that the father of the famous Victorian engineer Isambard Kingdom Brunel invented the very first factory where they made wooden pulleys called blocks for the ships of Lord Nelson's Navy in Portsmouth Dockyard? You can still visit it on special open days. It's a very, very historical site and very important because it was the first place in the whole world where somebody made a factory. But where can you find pulleys? We've still got them today in lots of machines and lots of uses. They're not just on sailing ships. So what you could do is to write a list or draw some sketches or take some photos of pulleys around your home or your school. Where will you look for them? Ask an adult. Don't go anywhere or touch anything that might be dangerous. Just look. Pulleys might be inside machines or in places where you could hurt yourself, hurt somebody else, or maybe damage the machine if you poke around inside it. If you've been given a workbook for this workshop, it's got a page where you can write and sketch your examples. Here's an example to get you started. I found it in my back garden. It's a washing line. Here we can see the pulley. The washing line comes out of the top of the pulley and I can pull it down here to lift it up with all the washing on so that the washing blows in the wind, in the sunshine and dries more quickly. So how do pulleys make a job easier? Let's investigate with Nikki, who's finding out if pulleys can make it easier for people to lift heavy loads like water from a well in very dry places, or for transporting fruit and vegetables to market in mountainous countries like Nepal. Here you can see a cable car system being used to bring the vegetables and the fruit from the mountains down to the valleys to sell them. We'll mention the cable car in Nepal again later, and maybe you'd like to try the Practical Action Squash Tomato Challenge when you know more about pulleys. First of all, Nikki weighs a bucket of water on its own. She thinks the mass of the water on the bucket is 5 kilograms. Check the scale in the second picture to see if she's right. We use the number inside the circle to read the measurement off. So here, this is 10 kilograms. Here's the pointer, and the 5 kilograms is hidden just underneath it. And then it carries on round to 0 kilograms, where the pointer would be if there was nothing hanging on the scales. So I think you'd agree with me that Nikki's right. I think this is reading 5 kilograms, halfway between the 10 and the 0. Now, Nikki's tied a rope to the bucket down here and used a pulley up here fixed to the hook at the top to lift the bucket. But she thinks it hasn't made much difference to how hard it is to lift. Do you agree with her? Check the scale for yourself. We've got a problem. The scale is upside down. This is because Nikki has to pull downwards on the rope to lift the bucket using the pulley in this way. But don't worry, it's the same scale. Here's the 0 kilograms. Here's the 5. We can see it this time because the pointer has moved a little bit, but not very much. I think that's reading about 4 kilograms. I think you probably think the same. So this pulley hasn't really made the job much easier. It only helps by letting Nikki pull downwards and maybe take a little rest if she wants to pull a heavy bucket of water up from a well. If it was a very deep well and the rope was very long, you might have to have a few rests on the way up. Aha, but now Nikki's had a much cleverer idea this time. She's fixed the pulley to the handle of the bucket down here and tied one end of the rope to the hook at the top. This is called a fixed point because it's not going to move. It's going to stay fixed. Look at the scale now. How much do you think it is reading? Nikki thinks it's about 2.5 kilograms, which is half as much as the bucket of water weighs. Do you think she's right? Let's check. Here's the 5, here's the 0. Halfway between 0 and 5 is 2.5, 2.5. I think she's right. But why has this happened? Think about it by yourself for a minute or two, and then we'll find out. If you've got somebody with you, you could have a discussion about it to see what their ideas are. Well, the reason is pretty simple when you have a good think about it. Look at the rope. It's been made into a V shape. Down one side, here's the point, and back up again to Nikki's hand. So Nikki is pulling on this part of the V. It's going round the pulley up here and pulling down on the fixed point. Let's follow it through again. It starts at the fixed point. It goes round the pulley, which turns and can move, and then back up here through the weighing scale to Nikki's hand. So now Nikki's hand and the fixed point are sharing the weight of the bucket. This section of the rope gets half. This section of the rope gets half. They get half each. Nikki's weighing scale on the last slide measured 2.5 kilograms, which is half of 5 kilograms. Using the pulley like this has made the job easier. It's a machine. The pulley will move up with the bucket as Nikki pulls on this side of the rope and it gets shorter. So it's called a travelling pulley because it can travel, it can move with the rope as you pull up on it. Okay, so now you know how it works. Let's see if you can work out the next one for yourself. Wow, Nikki's having a really good ideas. She's decided to see what happens if she uses 2 travelling pulleys. There's one, there's the other. Do you have any predictions? Remember, the trick is to count the number of rope sections. There are now 2 V shapes. There's the first one, there's the second one. And each V has got 2 sides. So that might help. How many rope sections have we got? 1, 2, 3, 4. Look how small the measurement on the scale is now. There's the 0, the 0 kilograms. The 5 is here. The pointer is hardly moved at all. Why is that? What do you think has happened? Can you use the prediction about the number of sides of the V's to work out why the weight looks so small now? Have a think about it for a short time, and then we'll tell you the answer in the next slide. Well, was your prediction right? Did you work out why the measurement of the weight has got so much smaller? Let's have a look again. There are now 4 rope sections making 2 V shapes. 1 V, 2 V's. 1, 2, 3, 4 rope sections. So now each rope section is holding 1/4 of the weight of the bucket. This one has 1/4, this one has 1/4, this one has 1/4, this one has 1/4. If we add up 4 quarters, 1/4 plus 1/4 plus 1/4 plus 1/4, we get 4 quarters. 4 quarters is a whole. So each of the rope sections holds 1/4 of the weight of the bucket. The measurement on the scale was 1/4 of 5 kilograms. Let's check the maths. 5 kilograms times 1/4 gives us 1.25 kilograms. So the pointer had only moved a very small amount on the weighing scales. Nikki only has to hold 1/4 of the weight along this rope section because the other rope sections are holding the other 3/4. This is amazing. It really works. This pulley system has made the job 4 times easier to do. Okay, though, one more travelling pulley problem for you to try yourself. This one's also in your workbook if you've been given one. Nikki didn't have 3 pulleys to try this out, so we've got to do it just through a drawing. If you were to pull where it asks you to, pull here, what will the measurement on the scales be? This time, the bucket and the water have got a mass of 6 kilograms, and the bucket's attached to 3 travelling pulleys. Now, let's remember the hints and tips. So what we do is we count the V-shapes. Now, I've drawn this and my drawing's not very good, so the V's are not very V-shaped, but I apologise for that. Here's the first V shape, 1. Here's the second V shape, 2. Here's the third V shape. We've got 3 V shapes. Each V has got 2 sides, so let's count the number of sides. 1, 2, 3, 4, 5, 6. And remember that the rule was that each of those rope sections, each side of the V, takes a share of the weight of the bucket. So if we've got 6 rope sections, they will take 1/6 of the weight of the bucket. So all we have to do is divide 6 by the total number of sides. 6 kilograms divided by 6. What is the answer to 6 divided by 6? Work it out, have a think about it. I'll move on to the next slide once you've done it. Good, I'm sure you did that. 6 divided by 6. That shows us how pulleys can be used to make a job easier. Oh, the answer to the last problem was 1 kilogram, by the way. I bet you got that right. So pulleys are very useful in many ways. If you look closely at sailing boats, you can see lots of pulleys being used. Here are some on the back of this boat, which are used to pull down on the sails and the mast to make sure that everything's nice and tight. There are about 3 pulleys down here and 3 pulleys at the top. You might have some building toys maybe at home though that have got pulleys that you could investigate. It's not just on sailing ships and sailing dinghies that we find pulley systems. You may have pulleys that you could build things with. You could look for pulleys around your home as long as you're doing it safely and you've checked with an adult that it's okay to do it. But the important thing is, from now on that you know about how pulleys work, try and work out what job they're helping to make easier. If you want to use what you found out to carry out your own project, which might use pulleys, then carry on to the next slide to find out all about the Squashed Tomato Challenge. So the Practical Action Squashed Tomato Challenge. This is a great project where you can use what you've learned about pulleys to make a model of a cable car system to help people in Nepal to transport fruit and vegetables to the market. All the instructions and the information are on this website, including a home learning guide if you can't do the project in school. If you do take the challenge, we'd love to see your final designs for the cable car. Send photos or videos of your model and anything you can write to explain it to me at the Abingdon Science Partnership. There's my email address. Thanks.